Hi, this video will be about vectors, but before we actually talk about it, let me ask you a question. Why are you watching this video? Probably online classes, or you're just really willing to learn about the topic. Well, just hang in there and continue watching, and we will try to explain vectors in a clear yet interesting manner.
What comes to your mind when you hear vector? I assume it also reminds you of something else. Scalar. In physics, quantities can be vector or scalar, but what exactly is the difference? Scalar quantities only have a magnitude. Take, for example, the temperature of your room, the volume of coffee you drank today, or the distance between you and another person. Scalar quantities only take account of how much or how far, but not where to. And that's why we have vector quantities. Vector quantities both have a magnitude and direction. Examples are velocity, force, acceleration, and displacement. I know there's always this question in mind for everyone. How am I going to use this anyway? So let's answer that. Vectors can be applied for a lot of things: military, projectile, gaming, designing roller coasters, and a lot more. But let's focus on one: navigation. Just like airplanes.
So now that we know what vectors are, let's talk about how to get the values. It is important to understand how operations like addition and subtraction are carried out on vectors. To add and subtract vectors, take note of the following. It is also important to note that the sum of two or more vectors is called the resultant. So this time I will be discussing the different methods of adding and subtracting vectors. In this part, we will not discuss more about parallelogram method, but vectors can be parallel or not. If parallel and it has the same direction, you add. And if parallel but in opposite direction, you subtract. If not parallel, that's when you use polygon or component method. So the steps in solving addition and subtraction vectors using polygon method are: first, draw the first vector using a scale. Connect the tail of the second vector to the arrowhead of the first vector. Draw a line from the tail of the first vector to the arrowhead of the last vector to determine the magnitude and direction of the resultant. And lastly, the length of the resultant vector drawn to scale determines the magnitude, and the direction is the angle between the arrowhead of the resultant. In adding two or more vectors by component method, each vector is divided into two new vectors called x component and y component. First is to resolve the given vectors in their x and y component. And second, add the components in the x direction to give rx and the y component to yield ry.
Let's check comprehension. An airplane travels 400 miles per hour 45 degrees southeast with an air current of 40 miles per hour west. Solve for the actual speed and direction using polygonal and component method. In polygonal method, we must always consider a scale, so we establish a scale of 40 miles per hour is equal to 1 centimeter. In polygonal method, we draw the lines continuously. To solve for the resultant and the angle, we must have a ruler and a protractor and come up with a 372 miles per hour and a 50 degrees southeast. In component method, we must solve for the x and y components of our variables. So the x and y component of a will be with a unit vector form of a is equal to 283 I hat minus 283 j hat. And the x and y components of our w will be with a unit vector of negative 40 I hat. And the resultant will be equal to 371.71 miles per hour with an angle of 49.58 degrees southeast.
Now we will talk about unit vectors. But before we begin, what is a unit vector? A unit vector is a vector with a magnitude of 1 without unit. Its purpose is to give the direction of the given vector. A vector can be expressed in terms of the unit vectors I, j, and k. If the components of the vector f are fx, fy, and fz in the x, y, z axis, then vector f and its magnitude can be expressed as Now that we know what unit vectors are, let's learn how to perform operations. First is the addition and subtraction of unit vector form. If your unit vector is like this, then the formula will be: for the dot product, the product of any two vectors in this operation is written as A dot B and is defined as the product of their magnitudes and the cosine of their included angle. In symbols, it can be written as. And lastly, the cross product. The cross product of two vectors A and B is defined as a vector f having the magnitude f equals AB sine theta, or A multiplied by B is equal to AB sine theta r, where r is a unit vector in the direction of the product. And the formula for these are the following.
Let's check comprehension. An airplane travels with unit vectors A is equal to 283 I hat minus 283 j hat with an air current with unit vectors W is equal to negative 40 I hat. Vector sum is equal to the sum of x components I hat plus the sum of y components j hat plus the sum of z components k hat. Substitute values and we will arrive at 241 I hat minus 283 j hat. Cross product. To solve for cross product easily, we must establish a table that consists the following vectors. The cross product is equal to AYWZ minus AZWY I hat plus AZWX minus AXWZ j hat plus AXWY minus AYWZ k hat, and we will arrive at the answer of negative 11,320 k hat.
And that's it for vectors. Thank you for listening, and we hope you learned something.